My name is Rafael Laita. I am from University of Lima in Peru, and I'm going to present you the paper Quantifying Uncertainty to Plan in Dynamic Environments. Today, in the age of information and knowledge, information is one of the aspects that adds more value to the enterprise. That's why we cannot manage information empirically. We have to quantify information so we can manage it scientifically. But how can we quantify information? The first attempts are found in thermodynamics, especially the concept of entropy that measures the amount of order or disorder that there is in the system, so the amount of information we have from the system. But the first one to make a mathematical theory of information is Shannon in 1948, where he quantifies information in a formula that relates the amount of information in a message with the probability of the event that the message is anticipating. For example, if I am in the North Pole and I receive a message that tells me that tomorrow there will be snow, this is a message with very little amount of information because it is highly probable that the next day there will be snow in the North Pole. In the other way, if I receive a message that says that an asteroid is falling to Earth tomorrow, that is a message with a lot of information for me because it is an event that it is not probable to happen. So the probability of an event is very related with the information that has the message that anticipates it. That's why Kolmogorov relates both of these aspects in a formula that multiplies the probability of the event with the logarithm of that probability. It is called the Kolmogorov entropy, and it measures the loss of information based on the probability that that event is happening. If we measure the quantity of information that we have, we can also calculate how long we can make plans, because the planning horizon depends on the amount of information that we have from the system. The more information we have, the longest we can plan. The more uncertainty we, we are from the system, then the shortest is the horizon we can plan. The maximum planning horizon can be calculated with a measurement that is called the Lyapunov exponent. In a unidimensional system, like the one we are studying, the Lyapunov exponent is equal to the Kolmogorov entropy. So we begin calculating the Kolmogorov entropy with a formula we have previously seen, and we make it equal to the Lyapunov exponent, and we inverse it because the inverse of the Lyapunov exponent is called the Lyapunov horizon, and it represents the maximum time we can make any prediction of the system based in the amount of information that we have from the system. Here is an example, very simple because we have only two scenarios in 3 trimesters. The scenario of the sales that can rise and the scenarios that the sales will fall, with a probability of each one from each trimester. This probability it has been calculated with a Markov chain because in the Markov chain the sequence of events depends only in the immediately preceding event, and that is how the chaotic system works. They only depend in the immediately preceding event. So we have three trimesters where only two scenarios can happen. The sales can rise, the sales can fall, each one with its own probability of event. Based in this prediction of scenarios, we are going to calculate the amount of information that we have from the scenario, and also for how much time we can make a certain planning. Then we calculate the Kolmogorov entropy for each trimester using the previously formula. So the first trimester we have an entropy of 0.881 bits, the second 1.79 bits, and the third one 2.7 bits. The units are in bits, that is the basic unit of information, and that is because the logarithm is in base 2. The next step will be to find how much information we have lost from trimester to the next trimester. By subtracting the entropies, we can find how much information we have lost. And we can see that from the second trimester to the third, we have lost almost 1 bit, and also from the first to the second trimester, we have lost also 1 bit. This is because we only have two scenarios, and both scenarios are have a probability very near to 50%. 50% of probability between two scenarios is the higher uncertainty for for a foresight. We it is totally random. We don't know which one will happen. So if like the probabilities we have chosen are very near to 50%, we are losing almost 1 bit. If the probability would be 50%, we will lose exactly 1 bit. And if we have more certainty, for example, like a scenario of 90, 95, 98%, then the entropy would have been less. But as it is nearly 1 bit, then the inverse is also 1. The units of time we are using is trimesters. So we can say that in both trimesters we can make a certain foresight of 1 trimester more. So by quantifying the loss of information through entropy, we can quantify the degree of uncertainty when we are planning, because that degree of uncertainty depends on the amount of information we have. The greater the entropy, the less information we have, and the higher rate of loss of information there is in the system. So the goal of foresighting must be reducing entropy. The less the entropy, the more information we have in the system, the more certain are our predictions, and then there also we can plan in longer terms. So we have to use the Kolmogorov entropy formulas to quantify the amount of information we have, to calculate the maximum horizon where we can plan with certainty. With the formulas, we can also see that the greater the entropy is when we have more scenarios projected. For example, if we compare the entropy in a system with or in a foresight with two scenarios with equal probability of occurrence, we will have two scenarios with 50% of occurrence each, and the loss of information for the next period will be 1 bit. Imagine we are calculating this in trimesters, so our Lyapunov horizon will be 1 trimester. It means we can make certain plans for the next trimester at the most. But if we have a foresight with 5 scenarios, all with equal probability of occurrence, 20% each, we will find that the entropy and the loss of information is 2.32 bits. So the inverse, the Lyapunov horizon, will be of 0.43 trimester, like 1.3 months, much more less than the previous example, where we have only two scenarios. It means that the more scenarios we have, then the more uncertainty also we have. And the smaller number of future scenarios, the lesser uncertainty of the projection. It means that if we can make more accurate foresights, we have to reduce the number of scenarios by a deepest research. This goes against all the common sense until now, where if we have a greater spectrum of scenarios, we are more prepared to what is going to happen. These formulas tell us the opposite. It tells us with more scenarios, the less we know. And now the objective is to have more information of the future. And in order to have more information of the future, we have to reduce the number of scenarios. The higher the number of scenarios, the higher the uncertainty. The lower number of scenarios, then the lower the uncertainty, and then also the longer terms in time we can plan. In conclusion, today information is the backbone of value generation of our time. So it must be quantified. We cannot manage information empirically. We have to measure it. We have to know the exact quantity of information we are disposing to make our plans. We cannot make plans without knowing how, how much certain we are about the environment, especially today, where the environment is highly turbulent, changes every day. So we cannot make long-term plans if we are not sure if our assumptions will be certain for long terms. So today there are two main steps that we have to do to design more accurate long-term plans. The first one is to set the maximum planning horizon. We have to measure how much information do we have, and with that we can calculate for how much time we can plan with certainty before the environment changes and all of our assumptions are obsolete. The second one is to reduce entropy increase in that horizon. Entropy increase is the loss of information. So if we reduce this entropy, then we will lose less information and we will have more certainty about the future. So we can make also more accurate foresight. To reduce the entropy, we have to limit the number of scenarios. We can do this with a more detailed analysis of each stage, and by reducing the number of projected scenarios, we will reduce uncertainty. Our plans will be more accurate, and we also can plan in longer terms of time. But we can only do this if we calculate the amount of information we have, and we can manage that quantity of information. We can make it more accurate, and we can decrease the entropy through time, so we have more certainty about the future and we can make more accurate plans. Thank you very much.